Hi there, my name is Shubham. I am a PhD researcher at Nottingham University in the United Kingdom. I am part of the Zephyr project, which is funded by the European Commission's Horizon 2020 Research and Innovation Programme. In my research, I focus on improving the technology behind vertical axis wind turbines in the urban environment by using softwares which can simulate the aerodynamic performance and noise generation of such wind turbines. In our quest for sustainability, we need to think beyond just solar panels on rooftops. Meet the vertical axis wind turbine, which are a much better option than the traditional horizontal axis wind turbines. Well, why? For starters, vertical axis wind turbines are more efficient in unsteady and turbulent wind conditions in the urban environment. Their omnidirectional design means they can accept wind from any direction, which is particularly useful in the unpredictable conditions of an urban environment. And with their simpler blade design, vertical axis wind turbines have lower manufacturing costs and require less maintenance since the electrical systems are located mostly on the ground. During my PhD, I used various softwares and numerical tools to understand the performance of vertical axis wind turbines. I used mainly two types of software, a high fidelity and a mid fidelity software. Now you must be wondering what is the meaning of these technical terms high fidelity and mid fidelity. Let me explain to you in a very simple way. Okay, imagine you are playing a game where you have to blow a feather across a room. You can use different types of fans to blow the feather, and each fan has different settings to control how much air it blows. High fidelity CFD software is like using a really powerful fan with lots of settings to blow the feather. It can give you very precise control over how much air you blow and where it goes, but it also takes a lot of time and effort to use. Mid fidelity CFD software is like using a simpler fan with fewer settings. It's not as precise as the powerful fan, but it's easier to use and still gets the job done pretty well. So high fidelity CFD software is like using a very powerful tool to get very precise results, while mid fidelity CFD software is like using a simpler tool that's easier to use but may not be as precise always. Therefore, if mid fidelity software can replace the high fidelity software without compromising on the accuracy and save us time, it's a win-win situation, right? Also, sometimes you don't really need to see all those tiny details. It just takes too much of time and can make things more complicated than they need to be. And that's what was one of the focus of my PhD, to compare these two methods for different types of geometry and operating conditions. In the process, I found out that mid-fidelity methods can be a good replacement for high-fidelity methods, where the overall design of a vertical axis wind turbine is not so complex. For example, when the wind turbine has one or two blades only, mid-fidelity methods can be used quite reliably as compared to the case when it has 3 or 4 blades. Another focus during my PhD was to understand the effect of design parameters like the number of blades, airfoil shape, and rotor size on wind turbines' performance and noise generation. A group of vertical axis wind turbines was also simulated to assess the performance of individual wind turbines when they are placed close to each other, like a wind farm you see sometimes near a highway. As part of the Zephyr project, Nottingham University has decided to install a special type of wind turbine called the helical bladed vertical axis wind turbine, which has a much lower noise than the traditional vertical axis wind turbine. The purpose is to do some experiments and understand the performance in real world conditions. The location you see behind me is the location where wind turbine will be installed in the coming days and is located in the Clifton campus of Nottingham University. So, if you have a chance to come by in the Clifton campus sometime, do have a look at the wind turbine which we have installed. Now, let's go back to my office. So I hope you understand the importance of vertical axis wind turbine and why we should care about improving the vertical axis wind turbine technology. Apart from urban areas, vertical axis wind turbines can also be a great option for floating wind turbines in the ocean, where horizontal axis wind turbines are more difficult to install. They have the potential to generate clean energy in between the sea without any human interference and noise constraints. Thanks for watching, and I hope you enjoy the summary of my PhD research on vertical axis wind turbines informative.